Hello, my name is Jim Seymour. I am one of the co-founders and Chief Technology Officer at E-Blox. We're here today talking to you live from, well, we'll call it our E-Blox studio here, because we realize many of you are at home, particularly children and young adults, with the closure of many schools and the turn towards e-learning. As a way to provide continued education at home. We know many of you are at home, and here at E-Blox, we design educational products that teach the fundamentals of STEM, STEAM, and STREAM through fun construction sets. So we're going to do our part in the e-learning process by having these live videos where we're going to build really fun things with E-Blox, like the things that you saw at the beginning of the video around me here. And we're going to talk about how the circuits work, how those circuits apply to the real world, and have a lot of fun. Okay? If you have E-Blox at home, you can build with us, okay, with these parts that we have here. If you're looking to get E-Blox, then you can have two methods. One, you can go to our website at www.myeblox.com. That's www.myeblox.com. Or contact your local toy stores, okay, and ask them about coupons, where we're going to be sending them coupons where you can buy and purchase E-Blox products at a discount through the toy stores, and we'll ship them to you, okay? So we're hoping by doing these videos that the STEM teachers out there will be able to use it as additional material for their e-curriculum. Homeschoolers and parents can use it as fun ways to continue the education on STEM. So, with that said, I, just like Superman turns into Clark Kent, I'm going to turn from Jim Seymour, CTO of E-Blox, to Dr. Edward E-Blox, also known as Dr. E-Blox. So, yes, Dr. E-Blox is going to be your host for these videos. We're going to be doing several of them over the next several weeks. Today, we're going to learn about motors and flying saucers, okay? So, if you have E-Blox at home and you have any of these sets that are shown right over to the right here, then you can have the right components, specifically the 91 battery module, the number 95 motor module, the number 62 switch, and the number 4 wire. Okay, if you have those, then start building with us. Now, if you read in your manual, in order for the motor to work, we need to produce a circuit, okay, a closed loop circuit. That means we need to build the circuit so current can flow from the battery through the motor and back to the battery, okay? And when that happens, then the motor will start running. So let's try doing that here. We'll build a little circuit like this and put the switch on. We put the fan on there and hit the button. Wait a minute, why isn't this working? Okay, wait, I've done this before. If you look, you gotta look closely on your motor module. There are some markings, okay? They show where the actual pin connectors are. The pins are only connected on one side and they make the electrical connections. So you need to make sure those pins are connected to the battery terminal and the 4 wire. Now put the fan on. There we go, we got it spinning. And then it says in the manual, if we hit it again, it should launch. Wait a minute, it's not launching. Let's see, when I look at this, this fan is spinning in this direction. And if I look at the blades on the fan, when it spins in that direction, the air is actually going over the blade, and that's going to push the blade down. It's not the direction I want it to go. If I could get the blade to spin the other direction, okay, then the air would go under the blades and it provide a force upwards. Now, one thing I know about motors is that if I reverse them, then the current flowing in the opposite direction will make it spin in the opposite direction. So let's try that. There we go, spinning, and now, oh, there we go, we got it to launch. That's pretty cool. We can try the yellow one here. Okay, spin, and Almost launched. Let's try it again. Ooh, there we go. All right, so we learned that when air flows underneath here, it provides a force that makes it go up. That force is actually called lift, okay? By the way, do you know why helicopters and airplanes choose not to use Uber to get to where they need to go? It's because they prefer to use lift. Okay, that's just the bad joke of the day from Dr. E-Blox, but you'll probably always remember that lift is what makes airplanes and helicopters fly in the air. All right, now, this was very interesting how this motor worked, okay? When current flowed through it, the shaft spun. And one of the things I noticed about this is that when I get a magnet near this motor, it actually is attracted to it. And that's because if you look inside of a motor, there are magnets in there creating a magnetic field, okay? The reason they do that is because now, if you study current flowing through a wire, you'll find that when current flows through a wire, it creates a magnetic field. And so if you look inside here, there is a bunch of wires spun around the part that makes the shaft turn. And so when current flows through it, it creates a magnetic field that's opposite in polarity to the magnet in there. And that force is what makes the shaft spin. Okay, that's a very high level description of how a motor works, but I encourage you to go online and search for commutators in motors to understand the full details of how a motor works. Okay, so now we've talked about how motors works and how it works in the circuit. What are some applications of motors? Okay, so like when I put it in this way where it doesn't launch, but it's a fan. Oh yeah, that's nice. A fan. Hey, I got box fans in my house, ceiling fans in my house. I bet if you look there, when you turn them on, they're turning on motors that make the blades of the fan spin. What other applications do we have for motors? Let's see. I love making shakes at home where I put ice cream in my blender, and when I turn that on, the blades in the blender spin around. I bet if I looked in there, I'd also find a motor. So another homework project for you is think about what are the kinds of things in your house that create a spinning motion. And look at those, like 5 to 10 things in your house and see if they have motors in them. All right, so we've learned a lot today. We built circuits to make motors spin, fans launch. We've learned about lift, okay? And we've talked about the various applications of motors. So I think that's a full day, but next time we're gonna talk and build our own FM radio and talk about what FM is and how radio waves work. So you're not going to want to miss it next time. Be there. We're going to do it around 3 days a week. And until then, stay safe and have a great day. Good.